right, geometry. Today we are going to explain your 3D pyramid project. So we are going to do a project where you will be building your own 3D pyramid that you will be constructing and building and then showing off its volume and surface area. So in this project, you will build and decorate a 3D pyramid of your own design, and you will calculate the surface area and volume of this object. As part of the write-up, you will show step by step how you arrived at the calculations of this. You will have 3 days to work on this project. It will be due May at the end of May 4th. So at the end of the period on May 4th, for your class or for you online students, you will be submitting pictures of your project and what you have submitted. So pictures of your work and pictures of your project that I will then grade from there. So in this so essentially you're going to be designing your own 3D pyramid, and you'll see what those. I'll show you some examples in a moment. So your day one is to first design your pyramid. So you'll design either a cone or a pyramid with a regular base, regular polygon base. A square base is fine. So if you want to do square base, that's perfectly fine. But a base with more than 4 sides is worth a special bonus. So if you get a pentagon as your base or a hexagon as your base, that's worth a small bonus. But it can be conical, it can be a pyramid, whatever your base you want. As a general guideline for the size of your object, the base of your object should have an area between 150 and 250 square centimeters. Overall, your object should have a volume between 750 and 2,000 cubic centimeters. So that is your guideline for size of your object. So you can't just create like a giant massive pyramid or like a tiny little pyramid. It needs to be within that size. So roughly like a little bit of a football size. I'll show you some examples as well. You may collaborate with the classmates, but everyone must submit their own object or drawing for the calculations. By the end of the day, you should have a scale drawing of a net of your object. So you are going to have a net drawing. I'll have an example on Schoology showing the if you were to like fold out your pyramid into its flat normal general shape. You should have a drawing showing all of its sides, all of its lengths, a scale, net drawing of your object with all the important dimensions labeled. So example, the radius or the apothem, if it's a regular shape, the base edge length, the slant height, the lateral edge length, all of that must be labeled on your shape. You may want to design, cut out, and test several prototypes before starting your shape. So that is what you should do on day one, which is today. Day two, you're going to do calculations in the presentation of your shape. You would need to draw a 3-dimensional picture of your object. So you'll want to draw a 3D shape. So you have the net drawing on day one. Now you want to draw the 3D shape. So all important lengths must be labeled in the diagram. For example, the radius, the apothem, the height, the base edge, the length, the slant height, lateral edge length, all that should be labeled. You would be calculating the base area and volume and surface area of your object for full credit. Show all your formulas you used, substitutions, and label results with appropriate units measured. So show me all the work that you got to get to that volume and surface area of your object. Show me your calculations. Be as thorough as possible for full credit. You would need to submit a neat sheet of calculations, complete with all the work and explanations in your own words. The clarity and accuracy and organization of your math work will make up the majority of your project grade. So showing me clear and precise results on how you got that volume, how you got that surface area is important. For those online students, you will be taking a picture of this and you will be emailing it to me to show me your work, because obviously you can't just hand it to me. And then the last thing you will be doing is actually constructing and building your object. So we will build in class or in class time if you're online. I'll provide basic materials like construction paper, glue sticks, tape. But if you want any fancier supplies, you will have to bring them. Those who are online, you'll have to create your own supplies. Every submitted object should be appropriately decorated, so make it look nice. I'll show you some examples of what students have done in the past. By the end of the day, you should have a labeled scale drawing of your net from day one, calculations in a 3D dimensional image from day two, and then a 3D decorated object. You can leave it in class and make sure your name is written on the bottom. Once again, those who are online, you will send me an image of all 3 of those. So send me 3 pictures of each of those different things, and on the backside of this, there is your rubric. So turning in this page neatly stapled to the two required drawings is worth 1 point. Your design, whether it's a pyramid with a square base, whether it's a cone, or whether it's a pyramid with a regular polygon base, like 5 sides or more than 4 sides, you can get up to 3 points for a maximum of 2, but up to 3 for a bonus. Your design follows the size guidelines, so make sure your that base is within the base parameters I set out in the volume. So the 150 to 250 square centimeters, and the volume between 100 and 750 and 2,000 cubic centimeters. So make sure you fit within those parameters. The draw, you have a 3D object is neatly turned in and created, so you actually build it. Your scale net is drawn and turned in and accurately labeled. Your 3D drawing is accurately labeled and turned in. Your volume calculations are all correct and precise and accurate. And then your surface area calculations are all correct. It is out of a total of 24 points, but it will be calculated as an assessment grade. So this will be worth the same amount of points as your assessment. Your rubric's just out of 24 points. So even though it says 24 points, it will be out of a total 100 points for an assessment grade. So this will be worth just as much as your most recent assessment, your probability assessment you just took. Let me show you some examples of some objects people have created in the past. Give me just one moment. So here are some examples of objects students have created in the past. So someone made an ice cream cone before. They used the conical base and made it a cone, and they calculated their surface area and volume of the cone, and then they just made it an ice cream cone out of for style. I have students who made like a pyramid, just general square base pyramid. They decided to make it out of a little bit more sturdy material, so they used cardboard as the inside, and then they sort of decorated and turned it into made it look like a nice little pyramid on the outside. Another student who tried doing they went for the more fancy base. They went for a regular hexagon as their base on the bottom, and they made this teepee wigwam type thing. They made it all nice and decorated and made it look pretty. But once again, they used a hexagon as their base, so they got that regular. They used that regular polygon, so they got that extra bonus point for doing that fancy base. So these are some examples, and gives you kind of an idea of the size of the pyramid. I believe this one was on the little bit of the larger side, while this one was a little bit on the smaller side. So somewhere between these two sizes can hopefully give you a better idea of how large this thing should look. Those are some examples. I will also post examples of like a drawing of a 3D object and a net drawing on Schoology, so you can see examples of those as well. But that is your project. Please let me know if you have any questions. Other than that, have a great rest of your day, and hope you have fun with this.